Well, hello. Today's Men in Mikey is something slightly different. One of our heat pumps has failed. We've got two here. And this guy here, I can show you what it is. It's a Daikin 16 kilowatt heat pump. Now, these guys have been here for almost 10 years now, and they've whirred away really without any major problems. So I shouldn't really grumble about it. But recently it has completely stopped. And it's come out with an E7 error, and an E7 error is all about the fans. I have also heard online quite a few scare stories about these fans, that when they go, that they take out the control board, which is really quite antisocial. And so I'm a little bit worried that may have happened in my case. So let's hope for the best. I also have to give a safety warning here, of course, so I'm going to pop the cover off. And before I do that, I'm going to turn the power off here at the back, and I'm going to leave it for 20 minutes. And the reason for leaving it for a while is that there are big capacitors in there, and the capacitors hold their charge after you've turned the power off, and they will give you a nasty jolt if you go anywhere near them. So, and also, needless to say, this is an advanced repair, so if you're a bit scared of electrics or mucking it in there, then maybe this one isn't for you, but it's going to be pretty intense. Let's give it a shot. Knows that E7 error, and you can find that in the service manual, which you can download fairly easily. I've just thought I'd provide a quick summary before I cut back to one of my lame videos. So basically, you check the power to the heat pump. Well, that's pretty flipping obvious, isn't it? Make sure the fan connectors are pushed in all right. Also probably not going to be the issue. Make sure you can twirl the blades around. I guess you could have a twig stuck in there, who knows. And there are some fuses that you can check, but I don't think you'll find those are blown. So quite honestly, that's when the fun begins. All right, well, here is the beast on the inside. You can see the two fan connectors here, ERSQ016A and 107. Popped those off and did some resistance checks. And this is kind of, so there's some information online about what you should measure. Okay, and this is what I found. Basically, everything is open loop, apart from pins 3 to 4, which appear to be the 5-volt supply to these fans. Sorry, 15-volt supply to the fans, which is a dead short on both of them. Well, that's quite annoying. I've tested this and tested this, and they are both dead short. So both of my fans are dead, and that really makes me worry about what's going on in here, because has it killed the board as well? Who knows? Anyway, I've got to change these fans, and so I'm going to do that first. Just want to add, I did check the fuse, by the way. Now, it says on the diagram here to check fuse F4U, but I think that's a misprint. And I think what they mean is this guy at the top, which is actually F6. There he is. Oh, and I did check that, and it's absolutely fine. Interestingly, this guy is a 5 amp fuse. 5 amp fuse. That is insane. I'm going to have a little word about that in a minute. Anyway, so that's where we're at. Out of curiosity, I thought I would measure the new fan before I put it in, just to see how it measures up. And as you can see from my table here, basically it's not quite as you'd expect. The only one that actually measures any ohms really is the pins 3 to 4, which is the supply line to the system. The other ones are basically open loop, which is really, I guess, well, that's what it is. I wanted to get my head around how on earth two fan motors could fail at the same time. I mean, that's just bonkers, isn't it? So clearly in my mind, one of these failed first and potentially caused the second one to fail, and potentially also caused the main circuit board to fail. So to get my head around what might have happened, what the sequence of events might have been, I've sketched out what might well be inside. This, of course, I don't really know because I can't get in there, can't see any way in. So I don't know what's in there, but for sure it's going to be something like this. So one day this fan motor is having a hard day, gives up the ghost, and let's say, for example, that it fails into a short circuit. So the motor windings melt down into a complete short. Then this transistor will be completely overwhelmed with the amount of current coming through it. And so that will probably melt down as well. And in melting down, that will potentially send a high voltage signal back out through here towards the control board, either on or both the control signal itself or on the 15-volt line. Meanwhile, this speed control signal is probably going to be all right because the Hall effect sensor is reasonably well isolated and it's very unlikely that any high voltage is going to get in here. So this signal, I would think, is all right. These two guys are pretty vulnerable. Well, if you've been watching carefully, you might have spotted that the new motor that I tested out was an 869, and this old guy that I've taken out is a 907. Now, the difference between those two is only the length of the wires. The 907 has longer wires because the unit is bigger and has a longer cable run. And I found the other ones online were a bit cheaper, and I came up with a genius idea that I would splice all these wires together instead of spending the extra on the version with the longer wires. Well, I can tell you that was a really pants idea. It took absolutely ages of fiddling about. And of course, you'd be so careful with moisture getting in. So I don't think I'd recommend that. I'm afraid to say I have completely failed in giving you some helpful video about how to replace these fans. There's a couple of reasons for that. Main one being that I've done the usual thing of taking two photographs, one at the beginning of a splendid video and the other at the end. And also it's flipping cold out here, so I'm not going to be doing it again. It is not that difficult to change the fans. It's a little bit twiddly. Take the covers off here, there's a few screws. There's a bolt at the end of the big blade, undo that. And then there's 4 screws inside to dismount the fan. The wires have to be undone and traced down through to the board. They come down to the bottom, through and then back up again. So you'll have to twiddle about with all of those. All in all, I would say changing the fans, it's not too bad, So give that a shot, don't worry about it. So I've now popped my new fans in, powered it on, and sure enough, I get a different error. I've now got a U2 error, I think it was. I'll better check that. U2, I'm pretty sure it's U2, which means there's no volts, which is more or less what I measured earlier. So there's no 325 volts. So something has died. Goodness knows if it's recoverable or not. But I'm going to have a go. Okay, this is a quick vid to help you get this bloody control board out, which is a real mare. So once you've undone a whole load of tie wraps, you can push this piece, these interlock into here, and if you push them up and then get 2 fingers in, you can slot these connectors, these plastic lugs out, and this board has just got enough flex to get your fingers in, and then inside there, you probably can't even see it, there are a load of connectors that you need to dislodge before removing it, and that's the best I can come up with how to do it. Oh, this little board comes off quite easily. There you go, pop that out, get your fingers underneath and mix it up. I wanted to give you a little bit of help trying to get this board out should you ever need to, because it's an absolute mare. And when I'm out there, it's not very warm at the moment. It's March when I'm doing this. And I really don't feel like doing videos about it. So while I've got it on the bench, I thought I could show you the process that I went through to get it out. As I've said before, you need to push in these 3 lugs to separate this plastic bit here so that you can lift it up and get to these connectors underneath, all of which will have wires plugged into them all the way down here. These are the really tricky ones that you have to get your hands in and pull them out one by one. And if you're really smart, you'll put some sticky labels on so you know where they go back into. I think, in fact, they're probably unique. I think they might have, because there's such a hodgepodge of connectors here. Possibly they're unique, so you can't get them in the wrong place. But anyway, I put sticky labels on mine. Get me. Next, there's this bizarre arrangement where the power goes into the unit. And these are the 3 terminals for the live, neutral and earth that supply the power to the whole thing. So pop those out. Also, there's your link here, F1, F2, that goes to the indoor unit. That needs to come off as well. So that should clear all the wires from down here. Then these 2 holes here are those regular hex bolts that you need to undo to loosen up this panel. And then that will get you underneath to these connectors that you can see here that are not actually obscured by this bizarre piece of plastic, but they're obscured by this bizarre piece of metal. So get this guy out of the way, pop these connectors out, and then you're on to the next stage. So with these bolts here undone, and this flappy, strange bit of plastic out of the way, the only thing holding it in now is this screw here, which is at the top. And there's a lug at the back. I probably can't show you, but if you push it upwards, then the unit will be more or less loose, and you pull it out with a strange sort of curly motion that moves it around and gets this big board here out of the way as you move it out. Oh, and I almost forgot, this is a connector to the big transformery looking thing that's actually an inductor at the top, so you need to pop that off as well before. Now at this point, you're still actually connected to the compressor at the bottom. And so what I did was, because I loosened all of the tie wraps, I could get the whole board still connected to the compressor onto the ground where I did the next bit. So there's these couple of wires here which route power through, out of this filter. So the power I think goes in here, through this filter protection networky board thing, and you need to pop those 2 off. Sorry, pop these 2 wires off so that you can lift it up. And then there's 2 screws here that get this plastic flappy bit off, and they also hold the other side of the plasticky thingy in here in. So once you've done that, you can then lift off this whole awful plasticky thing here out of the way. And that will get you to these 3 connectors here, these 3 screw terminals, and they lead to the compressor itself. So if you pop these 3 wires off, then the whole unit is free as a bird and you're ready to take it away. And at that point, you can either splash some cash and buy a whole new one, or if you really are insane like me, you'll give it a try and mend it. Right, the next part of the video is all about what I did to get my main board running again. And when I look back at the vids that I'd taken, there were some important things missing. So I've done a little extra bit for you to give some more details. And before I go into that, I also thought I should give you another health warning. I want to just tell you this is really a summary of what I did. It's nothing more than that. I don't have detailed, complete knowledge of this circuit. I just know what I found from the internet. And of course, you could make things worse. So please take care. Only do this if you're confident. But if you are going to do it, good for you, and good luck. So the first thing to start with, obviously, is going to be a visual check. So give the board a good look over for anything that's not right, particularly the capacitors. Capacitors do have a habit of dying, and usually when they go, there's gloop spills out everywhere over the top from the inside the big can. So check those out. And you can also measure the capacitance with a meter if you can get the wires on underneath, or get to the solder pads underneath. And of course, check around for anything that looks obviously burnt or dead. It can be a good clue to what might be wrong. I didn't find anything. Everything looked pretty healthy. So, but it's definitely worth having a good look. Next, it's a really good idea to check the main inverter power transistor module. Now, you can't actually see that from this side of the board. It's mounted underneath. But there is a procedure in the service manual with a strange title, something like method of replacement blah blah blah, but it's not that. It's a method of testing it. It's pretty straightforward. Use a meter to check resistance levels between the three compressor terminals and ground. Well worth doing. If you fail this procedure, then I think it's game over for your board. Right, the next place I looked was at these rectifiers. And basically, almost all of the power in the system goes through these guys, so they have quite a hard life. And they're very easy to test, so I thought good candidates to see if I can find something wrong with my board. As I say, there's two rectifiers. The top one there is a bit difficult to see behind all those wires. But the second rectifier, you can see pretty clearly. To test it, get a multimeter in diode mode and put it between the AC and the DC terminals. Where you can see I've soldered wires on because I was having trouble making contact. And if you test those, do them both ways and both terminals, so that you check all the different parts of the rectifier, and you should see a voltage drop across there using your meter in diode mode, about 1.4 volts, equivalent to 2 diodes. If you get open circuit or short circuit, then you've definitely got a problem. So there you go, well worth checking these guys out. That's where I definitely found a problem on my board. This rectifier with the wire soldered on was extinguished. Okay, so as the other rambling idiot is going to tell you in a second, the other place that I looked and found issues on the board is around the fan control outputs. So I just popped them in here for completeness and to show you a close-up of where I looked at the two diodes, and I checked the transistor. I found one dead diode, but everything else was all right. Okay, I've got this monster out on the bench here. I don't have a lot to go on. I mean, why can you not give us a schematic, Daikin? What I've got is this fairly lame diagram that's stuck on the inside of the heat pump. Open is what's dead about this machine. There seem to be two rectifiers here, but I can only see one on the diagram. And I mean, if you just see there, I mean, all you've got is really the outline to work with, but they've put some markings on the board. And this guy here rings out okay. This one does not. So there is nothing going on between the AC input here and the DC output. Problem is there's gloop all over this circuit board to try and keep the damp out of it because the unit runs outside. And so then I thought I'd better just double check that I'm not completely nuts about this rectifier that I think is gone. So I've soldered some wires on, and sure enough it is totally dead. And here's the main board flipped over. Took a few screws out to get it out, and there's some little catches down there you have to fiddle with, but it's not too bad. I've put some clean film on here because I don't want any crud to get on the heat sinks, because that would affect the heat transfer. Having a look around here, there's quite a few critters seem to be living in here, but otherwise it's fine. There's a tiny burn mark, I don't know if you can catch it just there. I'm a bit worried about that, but it could just be long-term heat usage. I'll have a look at that in a minute. And this is the rectifier that I was looking at from the other side. Definitely is a rectifier, a SD25XB60, and it's definitely dead. So I've got one of those in order. It's only £5 on eBay, so maybe that'll sort it out. Who knows? So then I got to looking at this strange sort of pseudo circuit diagram that they've kindly given us, and it seems there's two rectifiers shown on here. This looks like the main rectifier that provides juice to the inverter here, or the switcher here. And there's this sort of strange arrangement here. And as I look at the circuit board, I figured out that actually it's not the main rectifier that's kaput. It's this guy here, which is a little bit mysterious. So I spent some time trying to work out what on earth it's all about, because it's an unusual circuit, an unusual way of wiring up a rectifier. So I drew out the little pseudo schematic here of my own, and this is basically what's going on. Your 240 volts AC, I'm on a single phase here, comes in, and this is how the rectifier is kind of wired. with a transistor across the middle here, and the other side, so this is the plus and minus, well, it's normally the plus and minus output of the rectifier, and the other end tied to the middle of these two capacitors, which is all really quite a strange thing to do, because if you put two capacitors in series, you actually get half as much capacitance as if they were either in parallel or even just one on its own. So it's a slightly bonkers thing to do, unless there's a real method to their madness. And having a read about it, I think this might be what's called a snubber. What it's able to do then is so the transistor is a switch. So if you imagine you can connect that across there through this transistor, but you can do it, up to its absolute split second. And then that then shoots power to this midpoint of the two capacitors. Now, a rectifier, is a full wave rectifier, will basically take the AC, which would normally go up and down and up, and the negative part will just be folded back up here. So you end up with this ripple arrangement, which is the effective voltage. And if you left this on, this switch on all the time, that's what would come out. So the other important thing to note is that these capacitors are only rated at 210 volts. So they must have to be very careful about when they fire this transistor, because if you fire it up here, you're going to shoot 240 volts into the bottom capacitor, because this will be 240 volts here. Or if you fire it here at the 0 point, then you'll, apart from shorting out the 325 volts, you'll also be putting too many volts into this capacitor. So, as I say, I think they're doing something slightly canny here about when they fire that transistor. Okay, so to my next plan. So first of all, I've got a shiny new rectifier in here, so I'm definitely going to bob that in a few minutes. I also bought myself a new transistor, and one of the reasons for this is that I thought maybe this transistor had failed short, which I guess I forgot to explain to you a moment ago. But basically, if you imagine this transistor failed short circuit, then it's going to fry this rectifier anyway, because as you pull it down to 0 volts, the whole juice is going to flow from here through there, short out the rectifier, and poof. So it's not impossible that the transistor failed short. So I thought I'd change it over. It's not very expensive, £5 or something. And I might test the other one when it comes off to see what kind of state it's in. It's open circuit at the moment, although who knows, maybe I just haven't tested it through that gloopy stuff properly. Anyway, that's my plan. This is a quick shot of the back of the heatsink before I bolt the circuit board back onto it. I'm just going to show you there's plenty of gloop on here, so I'm thinking I'm just going to spread it around a bit. Okay, I've spread the paste around a little bit just to make a nice even layer. It's not important to have, it's important to have not too much on there, and that it's nicely spread out to give an even spread of heat. And then I'm going to drop this guy on the top. The new bits that I've put in are still loose, they're not soldered in, but I've spread the leads out so that they shouldn't drop off. And then we're going to drop this guy neatly back into its house. Then my plan is to find the hole, screw all these pieces back in, and then solder it up. So I'll be back in a sec. Right, I got all the screws back in now. Little top tip for you: try to make sure the screws don't fall through and get lost behind the circuit board, because if you do that, everything's going to have to come out again. Put them all back in. I put all the screws in here and the other ones around the outside, and I've tightened them up just as much as I dare. So I'm just going to solder these guys in place with a nice big blob of solder. That's a bit. So now I've got no way of testing it. I was contemplating powering it up on the bench here, but I just can't see the point. I've no idea what the thing would do. Half of the stuff isn't connected, so it would just throw wobbly anyway, and all sorts of lights would go on. So I don't think I've had any choice but to stick it all back in. and fire it up. I seem to remember also that I was going to talk about this fuse, this one here, which inexplicably is 5 amps. And so these fans are rated at 70 watts and they run at 325 volts. And if you do the maths, you end up with about 200 odd milliamps per fan, meaning that, you know, a half amp or a 1 amp fuse would be perfectly adequate. So I don't know why there's a 5 amp fuse in there. I'm sort of half tempted to downrate it, but probably it wouldn't have saved the fans because the energy, the voltage spike would have been extremely short, and may well have, you know, the fuse wouldn't have had time to blow anyway. So who knows? By the way, if you ever find yourself working on one of these machines, may I recommend you find yourself one of these, a post to shove this flipping awful door shut while you put the screw in at the bottom. Can't tell you how awful that arrangement is, but this is the solution. Okay, well, everything's back together. I've powered it on and it seems happy at the moment. So now the big test, I've actually got to fire it up. Of course, if it doesn't work, I'm probably not going to be publishing this video, so I can declare with supreme confidence that it's definitely going to work. And sure enough, I get a different error. I've now got a U2 error, I think it was. I'll better check that. U2, I'm pretty sure it's U2, which means there's no volts, which is more or less what I measured earlier. So there's no 325 volts. So something has died. Goodness knows if it's recoverable or not. But I'm going to have a go. Well, since I'm feeling quite depressed about my repair and it looks like I'm going to be spending quite a lot of money to fill this big hole with a new shiny control board, I wanted just to double check my compressor. So I've wired up this expensive meter which I've borrowed for a couple of days. It's showing my windings at 1.7, 1.8 ohms, so they look all fine. I also need to do a resistance insulation check. So I've done my resistance check now. I've connected to the windings and a piece of metal up here. And this machine will chuck out about 250 volts to check the resistance, the insulation properly. And it's showing at 20 odd megs, which is fine. And I've tested all three and they're all about the same. So reasonably happy with that. So just taking stock here of what's going on. As I say, I've put this board back into the heat pump after changing the rectifier and other bits and bobs. And what happened was one fan ran up for about 10 seconds and then it shut down, but it shut down with a U2 error and not the E7 or whatever it was, the fan error. Obviously quite interested in what's going on in these two circuits here. Now they're all laid out pretty similar. Now there's two fan outputs, which gives me a little chance to dot between them and see what's behaving differently. And this component here, which is a diode, I forget which one it is, but one of these it is a dead short and the other one it's kind of diode-ish. So that's my clues to what might be wrong there. Okay, so I've been racking my brain as to why it is that I've got one fan rotating, one fan not rotating, and yet the board is kicking out a U2 error. And the U2 error is all related to the 325 volts not being 325 volts. And so I've spent a bit of time on this board. Now I've got one diode, actually I've taken them both off currently. This diode was okay, and this diode was not okay. So you'd think obviously that this circuit here is the one that's broken and that's why the fan's not going round. But I've been working through the circuit and I've had a moment of inspiration, which means that I think actually it's the other way round, that this fan was moving when it shouldn't have been, which is marvellous because I think it could explain both. Let me tell you how that is. So I've spent a bit of time trying to figure out how all these bits and bobs are wired up around the fan connectors, particularly around the fan control output. And this sketch here shows roughly where they are. These are the two fan connectors. There's the diode that's working, there's the diode that's not working. and there's a transistor here and some other bits and bobs. And it's easy to explain if I look at this little schematic I've sketched out. So the transistor here is wired to pull up the fan voltage to 15 volts, definitely. And that'll be controlled by a PWM, pulse width modulated signal. I'm not going to bore you with an explanation, but Google will fill you in if you're not totally familiar with that. However, what it means here is that the protection diode here is wired up to 15 volts. So what that means is if the voltage here is ever above 15 volts, current will flow here. It will all be dumped through this diode into the 15 volt supply and hopefully keep the transistor and the other bits nice and safe. Now, this diode has failed, and it's failed short. I mean, this one here has failed short. And that means that the fan control output will be pulled permanently up to 15 volts. My assumption being that that means it will run full speed all the time. Whenever it's got 325 volts applied to it, it will be told go, go, go. And that, as it turns out, is quite interesting. If I flip now to the pseudo schematic that Daikin have provided us, you can see there's a big contactor here, and it's got two contacts, or maybe there's two contactors probably. And one of these goes through a resistor. And basically, this guy here provides a soft start or a safety mechanism for the board. So as it powers up, I'm pretty sure that this contactor will close first, and then current will go through this resistor, and I think that's probably either this guy here, or there's another resistor down there somewhere. This white thing I think is. And that will allow the system to charge up these capacitors nice and slowly, because they'll take an awful lot of juice if you try and power them on all in one go. And at the same time, it allows the system to make sure that everything is happy before putting on the second contactor, second big relay here, to pull the full juice through to the system. So that means that you can close this relay, soft start the system, and monitor the voltage, which I know that it does that, because we've sort of read it on the fault guide, etc. It will monitor this voltage. Now, if, as it turns out, one of these fans is rotating when it shouldn't be rotating, then it's going to be drawing quite a bit of power, around 75 watts. And that means that the voltage here is almost certainly not going to get up to its specified value, because the resistor will be taking quite a bit of power, losing volts across here as they're drawn into the fan down here. That means that with the fan running when it shouldn't be, the volts will be lower than they should be during the startup sequence of the board. And that means, ta-da, it could well be the reason why it's giving a U2 error. So that, in my mind, is totally marvellous. It means that I've found a credible explanation for why this diode here could be causing one fan to run, not the other fan to run, and a U2 error. I am very happy with that. So I've bought myself some shiny new diodes. I've bought a TVS diode, which stands for Transient Voltage Suppressor, and I'm reasonably sure that's what this guy here is. A TVS diode behaves more or less like a normal diode, except that it reacts very quickly and is designed to dump a lot of power, which is why they're actually quite chunky. And this guy claims to dump up to 600 watts. I'm not sure exactly how long it would survive that. But you can imagine that as this fan controller is melted, the fan control circuit inside the fan itself, it's probably melted, dumped 300 odd volts back in through here. This diode will then go, whoa, that's not right, and conduct it all and dump it up to here. And in that process, it has kind of sacrificed its own life. As we know, it's failed with a short circuit. I think it has done its job though, because I did test this transistor. Now you can look around on a transistor, and if you measure the voltage drop, a transistor basically kind of looks like two diodes. And so if you go base to collector and base to emitter, you should see a diode with a drop of about 0.7 volts. And both of these transistors, which is this one here, they seem to be, they ring out okay. So I'm kind of hopeful that This transistor has been saved from a fate worse than death, being fried, I guess. And so by changing this diode, hopefully the circuit will spring back to life. We'll just have to wait and see. So I've taken these diodes off, as you can see, and the way to do that, you really need 2 soldering irons, and you dab the soldering iron on each end so you can simultaneously melt the solder on both sides and then lift it off. It's a little bit fiddly, but very possible. So I've got them off, and then I cleaned the pads off with this stuff here, which is a copper braid that has a fabulous way of mopping up the solder. So you need to clean the pads off at least on one side so that the component sits neatly, because you can only really solder them back on one side at a time. So that's what I've basically done, clean the pads up, and then next I'm going to put a blob of solder on here, on one side of each. Then I'm going to embed that down in by melting the solder on one side so it sits neatly, and then I can move to the other side. So let's do that now. Okay, I'm going to fit this diode now. My plan here is to melt this blob of solder which I've added onto this side of the diode. Make a note, can you see the little stripe on there? The stripe points up towards the blue thing. I remember that from the last diode before I took it off. And now these diodes and all these components, many of them, surface mount components anyway, are designed to be fitted by a machine. A robot will go along and place them all down, and then it goes into an oven to bake them all in place. Which is one of the reasons why it's so fiddly, excuse me, it's so fiddly to do it manually, but it is all very doable. I'm just going to solder the second side here. I think that looks all right. There we go. And there we go, 2 shiny new diodes in place, and that's it, ready to go. I've decided basically this is the last ditch attempt to get this going again. If it was a bit easier to get the board in and out, I might try again, but it's cold out. All my days, you probably didn't need YouTube to hear the cheer. It works! You beauty! You fucking beauty!